Hey guys, welcome back to another episode of the Weekly Coder. I'm Chris, and this week we are going to be in episode 4 of Frogger. And with that, we are basically going to continue on from where we left off last. Wow, this is all like very extremely vague information for you, right? So basically what that means is we are going to continue on with our collision stuff, right? Because what we did is we made Frogger able to determine whether or not he's interacting with something that is either safe for him or not safe for him. So with that, we can actually add in the obstacles, like the traffic that he has to avoid in order to make it across the street. Because if we don't add any traffic, then the game is just going to be boring, and it's really not a game at all. It's just how much you want to press the up button on your keyboard, which to me sounds kind of boring, but who knows. Either way, I've prepared some assets for us to use. So let's start by adding those. So we're going to go into our graphics folder where we have all of our other awesome assets. And we're going to go ahead and grab all of the cars. And I've just named them green, orange, pink, purple, and white. Because, I mean, obviously the orange and the pink are cars. The purple looks maybe like a bulldozer, backhoe or something. The green is maybe a truck or some kind of tank. Or maybe, yeah. And then the white is definitely a semi. So, I mean, I could have gone with those naming standards, but I think colors are easier. So, let's just drag those into Unity. And there they are. So we've got green, orange, pink, purple, and white. So we're going to start by actually making sure that our pixels per unit is correct. And if I remember correctly, it's supposed to be 16 pixels per unit. And let's adjust our filter to be point, no filter. And let's just look at one of our other graphics just to be sure. So Frogger up, yep. There's a confirmed 16 pixels per unit. So that's what we're doing. All right. So the best way to do this is, since we already have the graphics, let's go ahead and create a script. So in the scripts folder, let's go in and create a C# script. Let's call this one, and for the lack of a better word, we could just call it car, right? Because it'll have properties of a car. It can drive, so it has a move speed. And that's pretty much it, a move speed. So with that script, we could go ahead and let's go ahead and actually put some stuff in this script. So let's open this up. What? That's interesting. So my computer's being weird. It just totally opened up mono develop and brackets at the same time. But it opened the script inside of brackets and then opened mono develop. So here we are with that. Here we got car. And car, like I said, is going to have a variable called move speed. And that's going to be, it's only going to move in the x direction, so let's just set it to be a float, and let's call it move speed. And we will set that equal to, I don't know, 5. Either way, we can change this in the inspector, which is what we're going to do. because we're going to have to test out how fast we actually want these moving, because they don't all go at the same speed. So what do we got to do? We have to move these cars. So in the update method, what we'll do is we're just going to say transform dot. Actually, let's do this. Let's create a new vector 2, because we can't just pass in an x property to our local position object, or to our local position property, because the local position x property and y properties are read-only properties, so we can't actually assign to those. So we have to assign to the local position property as a whole. So we have to have a reference that we can update and then later set. So what we'll do is we'll create a vector 2 and call it position. Nothing that we've never done before, but you know, I just thought I'd explain it a little bit. Vector 2 position, and then what we'll do is from here we are going to update the position variable. And actually what we need to do is we need to actually update this one with the current local position. So we'll do transform.local position. So that'll be the position of the transform of where the script is currently associated. Okay. So now that we know that position is going to equal the local position of the transform, we can adjust it. We can say, okay, well, position.x equals, or let's just say plus equals vector 2. Alright, you know what? We need to know another thing. Are these cars going to go left or right? So let's add another variable. Let's make this public as well, and we'll make it a boolean, and we'll say move right equals false. So by default they're all going to move left unless we say specifically that we want them to move right, and then we'll do in the inspector as well when we create our prefabs. So from here we can say if move right, right? So if we're moving right, then we want to move right, obviously. We'll then do position.x plus equals vector 2 dot right times move speed, oops, times time dot delta time. Can we do that? Yes. All right. And that was the reason that came up as an error is because vector 2.right is an actual vector 2, which has both the x and y values associated. You know, maybe I should take a minute and explain what a vector 2 is. A vector 2 is a type that you can use to define two positions, mainly an x and a y. It's also used commonly to define width and height, width being x and height being y. So if you ever want to store two positions in one variable so that you can access them later, you would use a type of vector 2, okay, and that actually stores an x and a y, and whatever you set to the x and y is what that vector 2 then stores. So if we wanted to store the position like we would create a vector 2 type of variable. We called it position, and right here we're storing the local position of this transform being whatever the script is attached to. At that point then we can say, okay, we can manipulate the individual properties of that vector 2 variable. We can say, hey, the x value of our vector 2 is going to equal this, and what this equals is basically vector2.right.x. Okay, so vector2.right is just an easy way to get at one unit to the right. Okay, so it would be the value of vector2.right, if you were to actually output that, would be 1x and y 0, okay? We would then take move speed, which is 5, multiply that by 1, which is 5, of course, and then we would times that by time.delta time being a fraction of a second from one frame to the next. Okay, so that way, if we have any weird framing issues, our distance will still be the same when we move. That makes sense? If we then take and say, you know, moving right, yes, that's all good and well. We're moving in a positive direction. But now, and let me just, okay. But now, when we're talking about moving left, we can still use plus equals because we're still incrementing x, but now we're going to increment it by vector2.left.x times move speed times time.delta time. Okay? So we're incrementing position.x by vector2.left, and vector2.left is simply just x equals -1 and y equals 0. So we're getting the x value of vector2.left, which is -1. We're timesing that by move speed, which is 5. So we end up with -5. And then we times that by time.delta time, which again is a fraction of a second. So it'd be like 0.0001 something. Times negative will then give us a negative number. So then we're incrementing our position.x variable by a negative number. And then finally, we take what our current position is, right? We say, hey, transform.local position is now equal to position, because this position is now updated with new values because the car moved, and we're going to change our transform.local position to what this position currently equals. And then once we loop back around, because this is the game loop in the update method, we then set position again to transform.local position, which remember is now equal to that position that we just modified. And that's how we get the car to move. So far, so good, right? Everybody still with me? All right, so let's get out of this for a second and go back into Unity. And we're going to just practice with one car. Okay, so we're going to go into our graphics folder, and we're going to drag out the orange car. All right, and let's put that at a Y position that looks right. I'm going to say -5. Yeah, looks good. And let's just put it at 3. Okay. So we've got this car sitting at 3, -5. Okay. And that is our car. Now, you'll notice we don't have colliders on anything because we're not using the physics engine. So we're not going to actually utilize Unity's collision detection system. We're building our own. Which is fine for a game like this because it's very, very simple. Very simple collision detection. There's nothing complicated about what we're doing here. So we're fine using just that. We don't need to worry about it. If we go into the car now, okay, this needs 2 scripts. First, we're going to add the car script. And second, we're going to add the collidable object script. And at this point, it's not a safe object, so we're not going to mark it as such. And the move speed, let's keep that at 5. The move right, no, because this one's actually going to move left. So let's just see what happens when we press play. My prediction is that the car is going to move at somewhat of a steady pace across the screen and then disappear into the nothingness. Okay. So, anybody see a problem with that? We need to have that car loop, right? So, once the car goes, we got this here. And let's just simulate what's going on here. The car's moving. Right? Car's moving, car's gone. Right? So as soon as the car disappears behind this, as soon as the car gets here, what we want to do is we want to say, hey, the car's position is now equal to 10. So let's make the car's position equal. Oops, that's negative 10. Yeah, the car's position, when the car's position is less than negative 10, or less than or equal to negative 10, then we set the car's position equal to 10. That should be good enough. So let's make that modification. Let's go into the script. Car. All right. So just before we're setting the position, we're going to say if transform dot local position dot x is less than or equal to negative 10, then we want to set the position. Actually, this is wrong. Because we haven't updated our local position yet, we need to actually work with the position variable, which is exactly right, which is what we want to do. So if position.x is less than or equal to negative 10, then we want to say position.x is equal to 10. But we only want to do this if we're moving in the left direction. So we'll take that if statement, we'll put that inside this else statement since this is when we're moving left. And just so that we're 100% clear on this, I'm actually going to do this here. Moving left. And moving right. Just so that we have some notes here to let us know that we're actually moving in the direction that we think we should be moving. Alright, now we're going to do the same thing here, is if position dot x is greater than or equal to 10, then we set our position dot x equal to negative 10. Alright, so that should solve our looping problem. Let's have a look. There we go. So our car goes from one side of the screen and loops around to the other. Perfect. So we're getting closer to having a prefab. What else do we want to do this? We want to know if the frog is going to collide with the car. So let's have a look at our player script and see what we're doing here for checking collisions. We are getting an array of game objects that have the tag collidable object. So there's my first thing. We have to make sure that we tag this as a collidable object. And that really is all there is to it. If it's safe, it's safe. If it's not safe, it's not safe. Alright. So let's go back in here. And let's go ahead and tag this thing as collidable object. And let's go ahead and click play again. And let's go out here. Boom. Not safe. See, every time see this number? It gets incremented a couple times every time the car passes through Frogger, whatever, the player, because we now have the collision updating. Because this is a collidable object, it checks that collidable object to see if we're ever colliding with the frog. If we are, then we're not safe, and we technically should die and just get reset back to the beginning. And we can do that very simply by saying, instead of, so let's go back into the player script, and instead of just saying, hey, we're not safe, let's also do something else here. Let's say that the transform dot local position equals a new vector 2, and then we're just going to pass in the original. Do we have that? Are we storing the original position? No. what is the original position? Easy enough. What we'll do is, let's go back in here and let's create a vector 2, and we can just make this private. Vector 2 original position. So then right when the game starts, we're going to set original position equal to the current position of the transform. So we have a reference to where he started out. So then we just say transform.localPosition equals original position. So we're basically resetting him back to where he started. So let's try that out. And that did not work. Did I put that in the wrong place? I put it in the wrong place. Alright. There. Now we should be getting reset back to where we're starting. Bam. So as soon as the player collides with the car, he gets reset back to where he started from. We should also update his sprite to be the up sprite. Let's go back in here. Transform dot get component sprite renderer sprite equals, what did we call that? Is it? Did we just? No. What did we call that? We called it, oh, player up. Alright, so now when he gets reset, not only does he go back to his position, but he also assumes the proper position of his starting position. So let's go ahead and run into oncoming traffic and stop moving after we do. There, we get reset. There. Okay. So now I would say that we could take this car and we could set its speed. I don't know, maybe a little, I don't know, let's have a look. Let's look and see what the original Frogger is like. Yeah, these move much slower. Alright. Let's see what we can do here. Set this down to like 3. Okay, I'm happy with that. Also, there are 2 cars. And the way it looks like they are positioned is that one car is right about here, which would be at -8. So let's go ahead and make a prefab out of that. We need a folder for prefabs. So let's just drag this in from the hierarchy to the prefabs folder. Alright. And let's put another one of these out. And it looks like this one is going to be right about here. So that's -5 and 1. So let's see what that looks like. Nice. Alright, so what we can do is we can go ahead and drag in the rest of the vehicles. So we've got this purple one, which is going to sit at kind of in between those. So let's do -4, and let's put him at -4, and we'll add the collidable object, and we'll add the car, and that one is moving right, and let's move that one at 4. And then we will make sure that the tag is collidable object. And then we'll create a prefab. And then we'll drag another one out. And then that'll be, let's put it at 5 and -4. And then we've got the green one. Let's grab that one. What direction is the green one? Goes... Okay, so they just alternate directions. Okay. So the green one's going to go left. And again, we're going to add car and collidable. Oops, not that. We don't need collidable. And that one's going to move, yeah, left. Actually, you know what we forgot? We need to go into the prefab. And actually into the prefab. That's the orange one. Hang on a second. How is... Oh, never mind. Okay. We're fine. I don't know what I was thinking just for a second there. Alright, so we've got green. I thought we needed to check is safe, but obviously not because the car is not safe. So we've got green, and green is going to move left, so we don't check anything. Let's go ahead and make this move at like a very slow pace, like 2. And let's go ahead and create a prefab after we set the tag to collidable object, because that would be the one thing that would make it not work. Oops. So it's actually supposed to be in the prefabs folder. Alright, so then we'll drag out like 3 more of those. Okay. And then this one, let's throw over here. Let's set the Y is going to be like -3. And then we're -5 for the X. -3. Oh, and you know, if you guys don't want to sit through all of this and position all these cars, feel free to jump over to my Patreon and become a supporter, and you will have exclusive access to download all of this content. The project files and everything are going to be available for you there. So check that out. I'm going to do -1. Negative, no, god damn. -2. Yeah, let's go with -2. And then -3. And let's go with 4. And then this one, also -3. And then let's go with, let's see, this one's -5, this one's -2. This one is 4, so this one should be 7. Alright, now let's grab the pink car. Let's throw that up there. And let's add our components. Collidable object, car. That's going to go right. We'll make that one at a 5. And the position of that Y is going to be -2. And then that one will make -3. Or maybe -4. Nah, let's make it -3. You guys can play with these positions. These are like, I'm trying to get them as close to what they are on the original Frogger as possible. I'm not doing such a good job at that, I think. Yeah. Yeah, feel free to mess around with these. Let's go ahead and tag this as a collidable object. And let's create a prefab for pink. And then let's drag another pink. And that one is going to be like right around here. So -2 and 6. Right. The last one is going to be the Great White. That one's going to be a -1. And we'll put that one at -5. And then we'll do collidable object, we'll add component, add car, and then add collidable object as a component. And it's going to go left, so we don't have to check anything off. Create a prefab. And then drag in the prefab. And that one's going to be right about here. So that's like 4 and -1. And there we have it. Okay. Let's have a look. Look at that. It's traffic. We now have obstacles. Haha. The game has now become challenging a little bit. Right? Isn't that cool? Whoa. Yeah. This is awesome. Now if we go, we can't even go to the water anymore because the water's not safe. Shit. Alright. I'm going to call that a successful episode. I think that we should probably stop here. Maybe the next episode what we'll do is we could either implement lives, like a lives counter. We could implement the countdown timer. We could implement, we can't really, well, I mean, he gets score for, I don't know. We'll have to look at scoring. I'm not sure about scoring yet. I haven't really actually looked into that. We could look at adding in the logs and the lily pads. So there's still plenty of stuff to do here. We still need to get to the actual like other side and win. So that's also a thing. But for now, and then later we need to look at other levels. You know, what do we do to actually make these more complicated? And obviously that would be to add more cars, make them go faster, more traffic, just like crazy amounts, and yeah. So, all of that said, I'd like to thank everybody for being a subscriber, for supporting the Weekly Coder. I know that some of you have already jumped over to Patreon and supported me there. It's really, really small donation. You know, we're looking at $5 a month. And that gives you exclusive access to download all of my project files for every tutorial that I post on YouTube. I think it's a real small price to pay for the work that I do here. Use that information at your own discretion. If you think it's worth it, do it. If not, that's fine. I don't discriminate against everybody here. I love all you guys. So again, check out my Patreon. It's really super awesome for you guys when you support me. I enjoy it. I mean, like I said, it's not about the money. It's just about, well, I mean, it is sort of about the money because I do spend my time doing these things, and I don't want to go on a rant here. But support me on Patreon. It would be awesome if you did. And don't forget to check out my new channel with my brother. It's called Code Scruffs. There's links at the bottom. My wife actually also has now a channel up on YouTube. She's doing a gaming channel, so she's doing playthroughs, and right now she's doing a playthrough of Skyrim, The Elder Scrolls, and the other playthrough I think that she's working on is Spyro, the remastered edition, I believe. So if you guys want to check that out, I'll put a link down in the description. She could use some subscribers and some likes on her videos as well. Those are actually kind of fun. So if you need a break from all this programming, and you want to give your brain a rest, go check her stuff out. It's really good. And Code Scruffs if you want some laughs, because that's just a crazy channel. So have fun with that. Again, thank you guys so much for your support. If you like the video, give me a thumbs up. Don't forget to subscribe and click the bell for notifications, and I'll see you guys next week.